part A, determine an equation for the inverse. So to find an equation algebraically, one, the common theme that has happened so far in everything with the inverse is that your x and y get switched. So they're going to switch algebraically as well. And then two, you're going to use those skills algebraically to rearrange an equation, what we did at the start of this unit, to solve for y. So in my original equation, I have y equals negative x squared plus 4. In my switch, I would have x equals negative y squared plus 4. And we want to get y by itself. So we could subtract 4 on both sides. And we're getting close to getting the y squared by itself. We could multiply both sides by a negative 1, which would give us negative x plus 4 equals y squared. And once you've got y squared by itself, you can now square root both sides. But you have to remember that plus or minus that we talked about earlier. So we get plus or minus square root of negative x plus 4. Part B says sketch the graph and its inverse. Well, the original graph is easy to graph with transformations. We've got a negative x squared plus 4. That means we have a regular parabola. The negative would be a vertical reflection and then a vertical translation 4 units up. Can you imagine your parabola flipped down and then shifted 4 units up? Question? Yes. So can you see that right here? You just switch the x and the y, yeah? Algebraically, you do the same thing. You just flip where they are, and then you have a new equation that you solve for. So on our parabola that's been flipped upside down and then shifted 4 up, can you see that you'd have the point 0, 4? You'd also have the point 2, 0, negative 2, 0. If we wanted to sketch the inverse on the same graph, and I'll graph the inverse in green, what's going to happen to 0, 4? It's going to be 4, 0. What's going to happen to 2, 0? 0, 2, and negative 2, 0, 0, negative 2. You can imagine the line y equals x going through there. And wherever that crosses, you can also add, there's going to be a point there, there's going to be a point there. And now imagine flipping it. We're going to get this graph. Yes? I did a couple of things in my head. I did the over 1, down 1, over 1, down 3 to get those. You could also factor it or look at the equation and say, if I put 0 in for y, can you see that 2 squared and negative 2 squared would make it 0? But for the most part, I took my regular parabola and I had my points memorized on that. When I flipped them down and moved them up, I saw where they went. So whenever we're doing a graph of our main functions, we want to have that parent function really well known so that we can see where the points are going to go. Okay. Something about the graph that I want to point out at this point as well. So we've got our parabola in blue. We drew our inverse using our graph. Another way that you could have drawn your inverse is using the equation. This is going to be a little bit trickier, but it's worth looking at. The equation actually can be written in 2 different parts. one with the positive, negative x plus 4, and one with the negative, negative x plus 4. Using your transformations, can you see that those are square root graphs? Okay? What does a negative do in a square root graph? It's inside horizontal reflection. Okay? Why do I have to be careful with the plus 4? Because it's not written in factored form. You might have thought 4 to the left, right? But I would have to first write this in factored form. So now I'm going to take my square root graph, flip it horizontally over the y. Can you see that that would make a square root going in that direction? And then move it 4 to the right. I'm going to put purple dots under this half. And I'm going to put purple dots on the top part. Can you see that that's that graph flipped over, moved 4 to the right? And yellow dots on this one, because I have a vertical reflection over the x-axis. Can you see that that would do this? And then a horizontal reflection would do that. And then move 4 to the right. Can you see flip, flip, 4 to the right? That one matching up with the bottom part. And it's kind of interesting because an inverse undoes something else. That's what a definition of an inverse is. How do we undo squaring something? We square root it. That's the inverse. Have you ever noticed that the graph of the square root graph follows the same patterns as your x squared graph? Right? You went over 1, up 1 over 1, and then up 1 over 3 on your square root graph. Matches up with your parabola over 1, up 1, over 1, up 3. In fact, when you draw them, a square root is really just half of a parabola turned sideways. Is, in part C it says, is the inverse a function? In this case, no. It doesn't pass the vertical line test. Is an x value with 2 y values. If I drew a vertical line on that green graph, I'd hit 2 y values almost everywhere. So that makes it not a function. Okay, questions 5 and 6.